Okay, you guys, here we go. We're getting started. Chapter 7, or Unit 7, I guess, is all about graphing. Okay, and so we've spent all last unit factoring, completing the square, doing all these solving things, which is great, but now we can use those tools to make really good graphs. So that's what we're going to do for 7.0, and we're going to give each of the tools that we learned a name. Okay, and what purpose they have for us. Okay, so the first thing we're going to talk about is we're actually going to use this equation right here. F of x equals negative x squared minus 4x plus 5. Okay, what you're probably used to is plugging in points for x and getting y's to come out, which is great, but that can be really time consuming and doesn't necessarily give you good information. But if we learn about these three forms, we can take this original equation and we can learn a lot about what the graph looks like. Okay, the first form is a form that you already know, and it's standard form. And it says standard form y equals ax squared plus bx plus c. That should look familiar to you. Okay, when we use that form, we can tell which direction the parabola opens, and that's going to be, it's either going to open up or down, meaning it's going to be a U that opens up or a U that opens down. Okay, and what else standard form tells us is this y-intercept. Okay, and your y-intercept, okay, is where it crosses your x-axis. The nice thing about that is we get these two pieces of information in two places by just looking at it in standard form. Okay, the direction of opening is the sign in the front, or what is A? Okay, is A positive or is A negative? Okay, if it's positive, it's going to open up, and if it's negative, it's going to open down. Okay, this one, the y-intercept, we find from C. Okay, C is our y-intercept. So for this specific equation, the equation we have, that's y equals negative x squared minus 4x plus 5. Okay, our A is negative 1. So that tells us it's going to open down. Okay, and our C is 5. So our y-intercept, which is a point, is when x is 0, y is 5. So by using those two pieces of information, I'm going to put those points on here. I know that it goes through 0, 5. I'm going to put that point. I also am going to make a note that this guy needs to open down, because if I draw it and it doesn't open down, I've made a mistake somewhere. Okay, that's what standard form does, and it's kind of a good starting point. Okay, the next one that I think is a bit more helpful is factored form. Okay, factored form tells us the zeros. We've done this. Okay, this was last unit. This tells us our x-intercepts. Okay, 90% of the time, okay, you will have two x-intercepts. If you do not, you will have one or none, meaning that the graph touches it or doesn't even come close to the x-axis. And we'll talk about that in another section. But main thing here, you factor the equation. So for this, I gave it to you, but just a refresher, we would go, first we would take the GCF out. We would say negative, and then we'd have x squared plus 4x minus 5. And we would say, okay, what multiplies to negative 5 and adds to 4? You go, okay, positive 5 and negative 1. So that's why it factors into x plus 5, x minus 1. Okay, and the zeros happen at the opposite signs, or when we solve. If I take x plus 5 equals 0 and I solve, and x minus 1 equals 0 and I solve, I get zeros at negative 5, 0, and 1, 0. So I'm going to add those points to my graph. Negative 5, 0, so that's here, and 1, 0. Yep. Okay, that helps. We're getting closer. Okay, we're kind of looking like a V, a U, kind of. Okay, we're getting closer. But the next form I think, in my personal opinion, is the best form because it tells us a lot. Okay. This next form is called vertex form. And vertex form is awesome because it gives us the vertex. And the vertex is the point, okay, the very top or the very bottom of that U. So the vertex in this situation is going to be the point that's at the very, very top, okay? It's your maximum point. So that tells us when we need to turn back around. The nice thing about this should kind of look familiar. You use completing the square to get a function into vertex form. So, a couple of things. I will do an example of how to go. Actually, I'll do an example right now. Never mind. The way we complete the square, if you remember, we go through and we're going to take this negative sign out. Okay, and we've got x squared plus 4x minus 5 equals 0. Okay, then I've got x squared plus 4x. I'm going to move the 5 over, plus something equals 5 plus that same something. So I take my 4, cut it in half. Remember, we take our b, cut it in half, square it. So b is 4, cut it in half is 2, square that, it's 4. So I'm going to add 4 to both sides. This factors into x plus 2 squared equals 9. Okay, I'm going to move the 9 back, which is opposite of what we did, but I'm going to move the 9 back over so I get x plus 2 minus 9 equals 0. Oops, x plus 2 squared minus 9 equals 0. And then I have to put this negative sign back. So if I make this one negative, I also have to change this one. That's how we get to that point, okay? The nice thing about that is we can look at this once it's in that form. We know the vertex is in this HK, H and K, but H is the opposite sign. So our vertex happens at negative 2, 9, okay? And our axis of symmetry is a line that splits our U or our parabola right down the middle. So our axis of symmetry is x equals, and it's always the K. No, it's not the K. Change that. It's always the H because it's what your x is negative 2. Ignore that on the notes. That's bad. Okay, so at negative 2, that's this line. X equals negative 2 is right here. That means that it's going to cut that graph in half. We also know the vertex is at negative 2, 9. So this is where we flip around. Okay, so if I've got a pretty good graph here, but I can add some other points. This axis of symmetry tells me that whatever points I have on the left need to match the right. So this green point, this y-intercept, I know that I'm also going to have this point because it's symmetrical. So I'm going to add that, and then I'm going to connect my dots. Okay, that's a pretty good graph. Okay, by using all 3 of these forms, we make a pretty good graph that gives us a good picture without just guessing and checking, which I think is really nice. Okay, watch the next video for all those examples. I'm going to do each of them and try to show as much work as possible. So watch the next one.